Today we are going to learn the power to a power rule for exponents. You should be on page 41 in your notes packet. When you are raising a power to a power, which means you have a base being raised to a power and then the whole thing is being raised to another power, you can multiply those two powers together. So in the case of a to the m raised to the n power, you would get a to the m times n power. To raise a power to a power, keep the base and multiply the exponents. In x to the third raised to the fourth, we see that we have the power of 3 being raised to the power of 4. What this really means is that we technically would take our x to the third power, which is x times x times x. And we would raise that to the fourth power, which means we would multiply this whole thing by itself 4 times. So we would have 4 sets of 3 x's. Well, when I look at what I really have is 12 full x's being multiplied by each other, which means that I have one x that is being raised to the 12th power. An easier way of getting that is taking my exponent of 3 and multiplying by my exponent of 4 to get my exponent of 12. For m to the 5th raised to the 7th, I would do 5 times 7, which would give me m to the 35th power. For k to the 6th raised to the 8th power, I would do 6 times 8, which would give me k to the 48th power. For a to the 9th raised to the 3rd power, I would get a to the 9 times 3, which would be a to the 27th. Now we can take the power to a power rule and we can apply it to products and quotients. If we have a product, which means we have a number being multiplied by another number, so in this case a and b are being multiplied by each other, and we raise that to the nth power, then we would have to raise each of those to the nth power. It's as if we are distributing our power into our parentheses, and every term in here would need to be multiplied by that power. So to raise a product to a power, you are going to raise both factors, or as many factors as there are, to the power, and then you need to always make sure that you multiply the exponents. For f to the 3rd, g to the 5th, all raised to the 7th power, you're going to take these and look at f first and then g second. Since both of those are in parentheses, they are both being raised to the 7th power. And since this is a power being raised to another power, you are going to have to multiply. So 3 times 7 would give me 21, which means that f is going to now have a power of 21. G to the 5th is going to be raised to the 7th, so that's going to be 5 times 7, which would give me g to the 35th. Now for 4r to the 2nd, s to the 9th, all raised to the 3rd power, there is a really tricky part here with this 4. The 4 does not belong to the r. The 4 is separate from the r. The r is being raised to the 2nd power. The s is being raised to the 9th power. But the 4, it looks like, is being raised to nothing. But remember, even if we don't see anything, there is always an invisible exponent of 1. So the 4 is being raised to the 1st power. So we're going to take the 1st power on 4 and multiply by the 3rd power. So 1 times 3 is 3, which means we now have 4 to the 3rd power. For r to the 2nd raised to the 3rd power, we're going to do our exponent of 2 times 3, which is 6, so this is r to the 6th power. For s to the 9th to the 3rd power, we have 9 times 3, which is going to give us s to the 27th power. Now you can always take 4 to the 3rd power and simplify that by actually finding the value of 4 to the 3rd power. So 4 to the 3rd power does mean 4 times 4 times 4, which would give us 64. So you also could write this as 64 r to the 6th s to the 27th. Number 7 says 2e to the 4th f to the 3rd to the 5th power. Remember that 2 does have an invisible exponent of 1. So we would do 1 times 5, which would be 5. So we would have 2 to the 5th power. E to the 4th power has to be raised to the 5th power, so we're going to do 4 times 5, which is 20. And then f to the 3rd raised to the 5th is 3 times 5, which is 15. So we have 2 to the 5th, e to the 20th, f to the 15th. Again, you can take your 5th power and raise 2 to the 5th power, so that would be 2 times 2 times 2 times 2 times 2, which would give us 32. And then you would keep the rest of this the same. Number 8 says negative 5x to the 6th, y, z to the 8th. Remember that negative 5 has an invisible exponent of 1, so that's going to be 1 times 2, which is 2, so we have negative 5 to the 2nd power. Then x to the 6th raised to the 2nd is going to be 6 times 2, which is 12. And don't forget about this y. This y does have an exponent. We don't see it, but there is an invisible 1 here. So we're going to have to do 1 times 2, which is 2. And then z to the 8th to the 2nd is 8 times 2, which is 16. Now we can take our negative 5 and raise to the 2nd power. Negative 5 times negative 5 is going to give us positive 25. And then the rest of this is still x to the 12th, y to the 2nd, z to the 16th. For the power to a quotient, just like with the power to a product, you have to take every part of your quotient and raise to that power. So in this case, if a was divided by n and the whole, or b, and the whole thing was divided by n, you would raise a to the nth power and raise b to the nth power. To raise a quotient to a power, raise the numerator and the denominator to the power, and then multiply the exponents. So let's simplify these expressions. For number 9, we see that x and y both have to be raised to the 6th power. Remember, they both have an invisible exponent of 1, so we're going to multiply by that 6. 1 times 6 is 6, so x becomes x to the 6th. And then 1 times 6 is 6 again, so y becomes y to the 6th. Now you can't do anything else with this because these are not like bases, so you have to leave them the way that they are. For 7b divided by c, all raised to the 2nd power, we have to take our 7b and our c and raise to the 2nd power. The problem is that 7b is a product. So sometimes you're going to have products within your quotients, and you have to make sure that you raise each part of that to the 2nd power. So 7 has to be raised to the 2nd power, and so does b. So we're going to have 7 to the 2nd power, b to the 2nd power, and then c to the 2nd power. 7 to the 2nd power is 49, and then we can keep b to the 2nd and c to the 2nd. So we would really get 49b to the 2nd over c to the 2nd. For 5j to the 4th over k to the 7th, we have to raise every part of this to the 3rd power. That includes 5. So 5 has an invisible exponent of 1, so we would do 1 times 3, which would give us 3, so this is 5 to the 3rd power. J to the 4th raised to the 3rd power, because it's a power being raised to a power, we're going to do 4 times 3, which is 12, so that's j to the 12th. For k to the 7th raised to the 3rd, we're going to do 7 times 3, which is going to give us 21, so this is k to the 21st. Now we can take 5 to the 3rd and simplify that. 5 times 5 times 5 is going to give us 125, so we could say 125 j to the 12th over k to the 21st. For 3n to the 5th over n to the 2nd, we have to remember that 3 has an invisible exponent of 1. So 1 times 4 is going to give us 4, so this is 3 to the 4th power. M to the 5th to the 4th means that we're going to have to do 5 times 4, which is m to the 20th power. N to the 2nd to the 4th means that we're going to have to do 2 times 4, which is n to the 8th. Well, if we do 3 to the 4th power, that's 3 times 3 times 3 times 3, which would give us 81. So this is 81 m to the 20th over n to the 8th.